All right, my Algebra 2 friends, we are learning more about linear equations. It's going to be super duper. You're going to feel like we did all this in Algebra 1, and that's true. So that's why it's kind of split up all throughout the two things here. All right. So key concept, first thing we're talking about is point-slope form, because I'm going to give you a point and a slope, and then we're going to drop those into the equation. Okay, this should look familiar, right? We just did y minus y, x minus x. Right, this whole thing. So we made this equation just by multiplying by this x minus x. All right, so that's how we come up with it. So if you ever forget, remember it is all minus in here. Nearly every equation you're going to deal with in your life with slope and some of those things and points are going to be minus minus. The only time that's going to change is the midpoint. So we'll get to that at some point as well. All right, so how's it work? So we have a couple things we're going to do. The line passes through -5, 2. With a slope, we have a couple things to do. We're going to write the equation in a line. So we're going to do that in point slope form. So y minus y, the slope, x minus x. So we're going to drop some things in here. Remember, this is x and this is y. So I got y minus 2. The slope, that was 3/5. And x minus -5. Well, we don't write double negatives. So we're going to make that +5 right away. So I wrote the equation in point slope form. All right, that's pretty easy. If I want you to graph, I'll find way too many of my students previously, they go ahead and they waste a bunch of time doing this, right? We don't need to do that. You're going to find the point -5, 2, 1, 2, 3, 4, 5. Just barely fits. 1, 2. All right, so here's the point that I start with. This is the first thing you want to do. Plot the point. The next thing you're going to do is apply the slope. So we're going to go up 3, 1, 2, 3. Okay, just barely fits again. And over 5. So here's where that point needs to line up to, and we just connect them. Okay, I do not need you, if the task is to graph it, please don't rearrange it, okay? That's a waste of time. All right, our time is precious, especially since we only spend a couple days a week together. We gotta make sure that we're being efficient about what we're doing. All right, we're gonna write the equation given 2 points. So this time I give you 2 points, but we're missing that slope, right? You're like, what are you doing, Mr. Rotolo? I wanted to slope this. This is gonna be so easy. All right, that's okay. You know how to find the slope. Yeah, you do. Don't argue with me. Here you go. So 8 minus 2. Remember, if I start with 8, I have to start with 5. So it's 5 minus 3. So far I got what? 6 over 2. We found the slope to be 3. Yay! Now you have to make a decision. I know, normally adults always tell you exactly what to do. Just make a choice. What ordered pair do you want to use? I like the small numbers. Right? You know, that's just the way it is, okay? So y minus, which one's the y value? Dos. Muy bien. And then it equals the slope times x minus the x value was 3. So I don't have to worry about double signs. If you chose the other one, you'd have y minus 8 equals 3 times x minus 5. All right, so either one of these, you do not need both. Remember, the task was to write it in point slope form, not write them both. All right, so if you want to ever double check, you can distribute, make sure you get exactly the same equation in slope intercept form, and then you would know that you definitely have it right. I'm not even going to show that because I don't think you want to do it, but you could. All right, next thing here. Standard form of a line. In Algebra 1, I'll be honest, you really don't like this. But here's the deal. As you grow mathematically, so now you're in Algebra 2, this definition changes just a little bit. So we need x and y on one side, that's for sure. A, B, and C are real numbers, and they are not both 0. All right, so for the most part, we're still going to stick to the fact that we need no fractions or decimals. We still want to make sure that we have integer numbers. Okay, so we're going to alter this a little bit to integers because that is still the SAT requirement. This is jumping ahead just a little bit. Okay, so we want to use integer coefficients. So I'll try and remember to put that on there so we don't get it mixed up. But the big difference from Algebra 1 to Algebra 2 is x is allowed to be negative. That's okay. So let me get my equation. Y equals 3/4 x minus 5. First idea is that I need x and y on the same side. So there it goes. I'm going to get rid of 3/4 x. These are unlike terms. So here's what I have. -3/4 x plus y equals -5. X and y are on the same side, but I have this problem, right? I have a denominator. So whatever that problem is, that's what we're going to use to fix it. When you're talking about solving equations by clearing out the fractions, same idea. So now I have negative 3x. When I distribute, these 4's cancel, so I just have negative 3 plus 4y, and don't forget this one. Right? This is the one I see kids leave off all the time. Now it equals negative 20. For algebra 2, we're in good shape. All I needed was integers. So a is negative 3, b is 4, and c is negative 20. So if I can make this list, then I know that I must have it in standard form. All right. Once it's in standard form, and we talked about this on the last video, is I don't want you to rearrange things. If I ask you to graph it, then go ahead and graph it. If you got 3x plus 5y equals 15, right? We have some prior knowledge about x-intercept is when y is 0. So that means we're going to completely ignore it. And we're just going to set up this equation. 3x equals 15. So x equals 5. Right? I want you to understand how this is an ordered pair. That is x is 5 because y was 0. Right? I know it's x equals 5 because I solved for x, so it has to go in the place of x. All right, now we're going to work on the other half of it here. 5y equals 15 divided by 5. Y turned out to be 3. So that means when I build this ordered pair, y is 3. Why did that happen? I completely ignored the x term because it had to be 0. Okay, so intercepts are all about the other one being 0. Super easy to graph. Now that I have this information all together, we said y is 3. 1, 2, 3. Whoop, there it is. X is 5. 1, 2, 3, 4, 5. That's my graph. Okay. That's a whole lot easier. Subtracting 3x and dividing by 5 and then trying to work with negative 3/5 and all that stuff. Right? Use the equation the way it's given to you. Right? I use the analogy of changing the tire. Yeah, you can do it with a screwdriver, but it'd be a whole lot easier if you do it with the actual lug wrench for the lug nuts. All right, so now you've graduated. You got the dream job you always wanted. Not exactly the dream employee, but the dream job you always wanted. You ordered 140 packs of printer paper. Based on the average daily use, you know that the paper lasts about 80 days. So we want a graph that represents the situation. What's the equation of the line in standard form? How many packs of printer paper should the manager expect to have after 30 days? All right, so we need to come up with an equation first so we can then graph it. All right, so what do we got? On day 0, we have 140 packs of paper. On day 80, we have 0. Okay, so the first thing we have to do is interpret what's happening here. And we're gonna have these situations happen. So let's find out how much paper we're gonna use per day or packs of paper we're gonna use a day. So again, I want to be consistent with my y values. So whatever I use first. So I'm going to go 140 minus 0. Okay, so that means I want to use 0 minus 80. Now think about this. If we're using up the paper, should my slope be positive or negative? Yeah, it should be negative, right? So we're going to deal with it that way. So I get 140 over 80. First thing I'll do is reduce by 10, and then I'll reduce by 2. Okay, so we're at 7/4 packs of paper per day. All right, so if I want to build up my equation, y equals 7/4 x. How much did we start with? Did we have the y-intercept already? You bet ya. Plus 140. All right, so clearly I'm not going to fit this 140 on my graph. So let's figure out a way to work with it. Okay. So let's go 1, 2, 3, 4, 5, 6, 7. Okay, so what I could do is 20 for each one of those. Okay. Yeah, so let's deal with that. So we got 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to mark 20, 40, so we get the idea. So this is 140. But I also am not sure I want to run this thing out to like the 80 days as well. So let's just go 20 down here, 20, 40, so we understand that that's how it's going to work. So what happens is, that means I'm going to go down 7 because we got negative 7/4, and then I'm going to run it out 1, 2, 3, 4. So there we get our line. All right, so now we have a graph that represents the situation. We had to come up with an equation, but it's not in standard form yet. So let's take that and turn it into standard form. So first thing I'm going to do while I'm rewriting this is I'm going to subtract this 7/4 x to the other side. So negative 7/4 x plus y equals that 140. Now the only problem that we have is this fraction, because I do want to put it in integer form. So that means we're going to multiply by 4. Whatever I highlight as the problem, that's what we're going to use to fix it. So negative 7x plus 4y. All right, so now we need to use, what do we got? 400. Let's go 4 times 40. All right, so we're 160. Okay, so we're at 560. So now it's in standard form. So that takes care of that standard form. And then the last one, how many packs of paper do we have after 30 days? All right, so dealing with this, I'd probably say that I want to use the slope-intercept form. Oh, I didn't put my minus in there. Good catch if you already had it. Probably angry. Why doesn't he have minus in there? Okay, now he does. 7/4 times 30 plus 140. So how many packs of paper do we expect to have after 30 days? So a couple things we can do is plug it in. That's item number 1, because we have an equation. Next thing I do is I can figure out where 30 days is and figure out about how many packs that is. So let's see how accurate my graph was. I don't think it was very accurate because I missed this point completely over here. It's not exactly the straightest line either, but you get the idea how I can work with all these representations. All right, so next thing I might do is reduce this by 2. This is going to be 15. Okay, so that's 7.5. That's 7. So 49. All right, so we get about 87.5. Okay, and that's going to be packs of paper. All right. So plugging it in, 40, 60, 80. Okay, so we're under 100. Okay, so my graph is a little bit off, but you get the idea how we can check it out here to see about where we're going to be, and then we should get that 87.5 packs of paper. All right, parallel lines. What do we know about them? The slopes, they're exactly the same. Okay, perpendicular lines, the slopes are opposite reciprocals. Okay, so negative we call opposite, and then reciprocals, right? That means we flip it. Okay, so that's what we get for perpendicular. Remember, that forms a 90-degree angle. Okay, so we're really studying those slopes and what happens. Parallel lines, remember the y-intercepts do have to be different. And perpendicular lines, we don't really care what the y-intercepts are. We're really focused on the slope. So let's see how we work with that. A line parallel to y equals 6x minus 2. Okay, so if I want to be parallel, that means my slope is 6. So I have to use that again. This is my new x and y. Okay, so I encourage you, if we're not using the y-intercept, just cross it out. Otherwise, we'll accidentally use it somewhere unless I have you work in point slope, which is what I'd like you to do because it's so easy. All right, so that means we had y minus -3, so plus 3. 6 was the slope, x minus 1. We do have to be in slope-intercept form in the end. All right, so watch how easy this is. If your Algebra 1 teacher didn't have you do it this way, you might be upset with them. Distribute and add or subtract this term. In this case, we're going to subtract y equals 6x minus 9. Look at that, we're done. I didn't solve for b and then have to rewrite it as if I were working in slope-intercept form the entire time. Okay, can I do that way and check it? Sure. -3 equals 6 times 1 plus b. So that's 6 plus b equals -3. Subtract 6. B turned out to be -9, and then I rewrite it. So totally your call. But if you're having trouble with it, I'm surely going to encourage you to use point slope form because it will work a little bit faster. All right, this time we want to be perpendicular. Perpendicular. So first I want to do is identify what's the slope. Slope is -4. So if I start with -4, perpendicular, there's our symbol, upside down T, needs to be positive 1/4. So this is my new slope, and it has to go through this point. So I'm going to cross out this other stuff because I don't need it. So 8, 5. All right, so I identified the slope. I did that. Use point slope form. Y minus 5 equals 1/4 x minus 8. Check, and rewrite it in slope intercept form. So this is a pretty normal process as far as a request that we'll work with. Distribute 1/4. Okay, 8 divided by 4 is 2. So that wasn't too bad. And now we're going to add 5 to finish this thing out. So y equals 1/4 x plus 3. Again, you can always use point or slope intercept form if you want to do that to check it. And I'm not going to spend your time on that. Okay. All right, let's see if you got it. What is the equation to each line in slope intercept form? The line parallel? Ooh. Is the slope 4? No. I don't know what the slope is yet because this is not in slope intercept form. So when we got to these got it questions, there's a little extra work to do. So I'm going to bring my equation down here. I can't tell what the slope is until I solve for just y. So what I'm going to do is subtract 4x. So I have 2y equals -4x plus 7, and I'm going to divide by 2. So now I find out that y equals -2x plus 7 over 2. Now they gave me an ordered pair to work with. So the first thing I'm going to do, I don't want to get distracted. I'm just going to cross out the y-intercept of the other one. My slope turned out to be -2. I'm going to again remind myself this is about parallel. So that means I'm going to use a slope of -2 and 4 -2. I do want to end up in slope intercept form when I'm done. But by now, you guys know that I'm going to run this thing straight through point slope. So y plus 2 equals -2 times x minus 4. Distribute -2x plus 8 minus the 2 minus the 2. So y equals -2x plus 6 becomes our final equation. All right, the line perpendicular this time. So this time we do have it in slope intercept form, right? So I start with 2/3. What's perpendicular to that? So this is positive. So I went -3 over 2. So that's pretty good. This is my new slope. And they gave me the ordered pair 0, 6. All right, now if I'm pretty smart, not even that. If I just remember, okay? So if I remember that 0 means something to me, if x is 0, then this must be a y-intercept. So what this point tells me is that b equals 6, right? And that has nothing to do with being smart. That has to do with having something memorized. Two very different things. So that means I can go straight to my equation. Y equals -3 over 2x plus 6. Okay, now if I forgot, right, as soon as I go and do this, y minus 6 equals -3 over 2x minus 0. I'll be like, oh my gosh, look at that. Because x minus 0 is just x. And then it would add 6 to this. So I would end up right where I was. Okay, so even if you forget about this little thing, remember if there's a 0, there's a chance that it's either an x or y-intercept. And if you have a y value, then this must be a y-intercept. Okay, so we can put those ideas together. All right, so I just want you to try out a few of these ideas. So we want to do these on the day that you're watching the video so that you're all set when you come into class, and then we'll build on those. So a couple tips that I want to give you is, all right, remember you can multiply by 2 right away to get rid of fractions. Right, so you might do that here with the 5. So at some point it has to happen. The other one in science class, right, you're going to deal with some decimals. Remember, the way to get rid of that, if I just don't want decimals, that's to multiply by 10. So I have a little 10 on there, so we can do that. All right, we want to find the intercepts and then graph each line. So I might take these, right, and we're just going to do our x-intercept and our y-intercept, and then throw those on there. Okie dokie. All right, more about linear equations.